Hello, this is Corbin Irwin, and this is a presentation for CYB 610 at Grand Canyon University. Let's talk about our goals and objectives of this presentation. First, we're going to identify a vulnerability and exploit it to gain root access within the Keyoptrix 1 machine. We're going to utilize that root access to then create persistence within the machine. We're also going to discuss several techniques that we would use to harden the Keyoptrix machine. We'll also discuss several common attacks seen within the cybersecurity space. So let's talk about how we actually gained access to the Keyoptrix machine. First, we booted into Metasploit. Once we're in the Metasploit console, we were able to figure out which version of Samba that was running. This was done using Metasploit, as I said, and identifying the version of Samba was pretty straightforward. We were able to see that we were running 2.2.1a within the Keyoptrix machine. This is exploitable. Our next step was to find an exploit we could run. Using exploit database, we were able to find Samba and the version number, and the following exploit was available. We copied it in raw format on our Windows machine and then moved it over to our Kali Linux. Using Vim and the command here, we were able to save it as a file and then compile it using the command here. Once the exploit was compiled, which we can see editing here and compiling here, we were then able to execute it. We executed the exploit here, and then we're able to further put in the rest of the information to help target a Linux machine with the following IP address, which is our Keyoptrix machine. Once that was targeted, we ran the exploit, and as we can see here, we were able to gain root access. So it's pretty straightforward, but we're not done yet. Our next goal was to add a new user. This was done by first locating the user add function, which we can see was found here, and then we ran the following command to add the user Irwin. It asked us to enter a password, which we did, and then we were able to add the user. Again, pretty straightforward. But we wanted to have some more privilege escalation for this account. We've established persistence, and next is our privilege escalation. So running the following command, echo, we were able to change all of the privileges to be the same as the root account. And then we were able to verify that using the category command. And as we can see here, all the privileges from the root account are mirrored to the Irwin account. We then logged in with the Irwin account, successfully completing the lab. And for fun, we did find the flag that they hid within the Keyoptrix machine. So we successfully completed the Keyoptrix 1. So let's talk about how we would mitigate such a technique. We were able to easily gain access to the system, but just as easily we could block that attack. One of the first things that we could do is look at which ports are unneeded and secure them or close them. There's many ports open within the system, and they didn't all need to be. We could also possibly use a VPN to access those ports and thus encrypt traffic, which would be another method of securing them. The easiest way to secure the actual attack that we use would be to update the software, the Apache and the SMB. This would have prevented the exploit used to compromise the system in this case. Another valid technique would be to reroute traffic to the system through a firewall, IPS, or IDS. These would have either blocked an attack, some of the scans that we're doing, especially the intrusive ones, or at least alerted us to them, having been the IT team, so that we could have looked into who was attacking our machine and what methods they might be using. Would have given us a little bit of a heads up. So all of these are valid methods for either mitigating the attack completely or at least being aware that it's happening. Next, we're going to talk about some common exploits and attacks that we see within the cyberspace that are important to be familiar with. The first is the buffer overflow. A buffer overflow occurs when a program enters data into a memory outside of a buffer area. As we can see within our picture here, we have our buffer space, and then sometimes it will write data past that space. If the information entered overflows into adjacent memory, it can cause crashes, data corruption, or even execution of arbitrary code, which is really what an attacker would be after. So basically, you write too much data, overflows a buffer, moves into adjacent memory, and sometimes will allow you to execute code this way. Privilege escalation. Privilege escalation and its related attacks are part of a cybersecurity attack chain. Privilege escalation is seen in the initial access of a system. Once initial access to a system has been achieved, the attacker will then use bugs, misconfigurations, or secondary exploits to gain escalated privileges. This allows the attacker to achieve greater control over the system and potentially establish persistence. Horizontal privilege escalation happens when accessing the privileges of a similar type user, and vertical happens when accessing increased privileges. So this is something that you're going to see commonly, something that we did in our lab where we wanted to gain more privileges. So we actually gained the same privileges as the root account. So in our case, we were doing vertical privilege escalation. Rootkits. A rootkit is a type of malware that allows attackers to access the system and its data. Typically, the goal of a rootkit is to allow attackers remote access to a system and stay undetectable. Rootkits are used to spy on users, steal information, use infected machines as part of botnets, and more. Rootkits often contain multiple pieces of software that work together to allow attackers access. There are several types of rootkits, such as firmware, bootloaders, application, kernel mode, and memory. Basically, the purpose of a rootkit is to sit in the background and allow access to hackers so that they can either spy or move things onto the computer, maybe other exploits, viruses, things like that. But while they're doing that, the rootkit stays hidden. So Trojans. A Trojan horse is a piece of malicious software that is bound to a legitimate software. Often this is done with software called binders. When the users launch the legitimate software, they also run the Trojan and allow the attackers to compromise the machine. Trojans vary from other viruses in that though they are malware, they do not replicate and require the user to execute them. Several Trojan variants exist and are classed depending on the type of payload they carry. So a Trojan horse can be attached to many different kinds of viruses, but its main purpose is that it moves in with legitimate software and then it is executed by the user. So backdoors. Backdoors are methods of accessing a system that forego the normal security operating procedure. Backdoors are sometimes purposely present in software and hardware to allow manufacturers and IT teams to access the systems at later points. Sometimes attackers will even use backdoors that manufacturers leave to access the system. When an attacker uses a backdoor, its purpose is to give them high-level user access without triggering the standard security protocols. Backdoors differ from exploits as they are purposely present in the system. So basically, a backdoor can be put in by an attacker or by a system engineer, for example, and it gives them access, escalated privilege access to the machine. An example of one of these being exploited was actually seen in the Nintendo Switch, where developer mode was accessed by hackers who were able to basically create a fault within the system that triggered the mode. This backdoor went through all the normal security procedures and allowed them to write directly to the kernel memory. Viruses. Several virus categories exist, but they all share similar characteristics. A computer virus is a malicious piece of software that, when executed, will take control of or cause damage to a system. Computer viruses will also typically self-replicate and attempt to spread within the current system or externally through emails, network devices, drives, and other shared media. Viruses are often attached to other legitimate files to trick users into opening them. Viruses differ from worms because they require user action to execute them. So a virus could be a Trojan. It doesn't always have to be the Trojan doesn't always have to be a virus, but a virus is most typically a Trojan, and they cause damage or cause immediate action within the system. Return-oriented programming. So return-oriented programming, or ROP, also known as chunk borrowing, is a technique of using stacks to execute binary instructions via ROP gadgets. This can bypass many code execution protections, such as address space layout randomization and DEP. Attacks will use stacks to redirect the return function to code to another location. This method can be used to chain code execution and achieve a similar effect to arbitrary code execution. So basically what it does is when the return function is used, it'll return it to a different location and run the code there instead. By doing this, you can chain them together to run different pieces of binary code that will allow you to execute different functions. So it's not quite the same as arbitrary code execution, but allows you to chain exploits together, or code together rather, to get a desired effect. It's very effective and hard to prevent just because of the way or the level that it works at, and because it does bypass a lot of those code execution protections. So now let's talk about social engineering attacks. There's many different types of this. You could go into the different categories for quite a while, but we're going to talk about some of the bigger ones. Phishing, obviously, is a widespread and typically targets the average user and attempts to trick them into basically logging in with fake websites and fake emails. The end goal is to steal users' information. Whaling is another type of attack that spoofs emails and fake sites, but it's targeted toward top-level officials within a business or government. SMS phishing, or smishing sometimes called, uses many of the same tactics as regular phishing, but is done over text messaging apps. This is very common in today's world. You see this quite a bit. And spear phishing. This uses the same concept of regular phishing, but is very specific with its target and will often be accompanied by personal information that the attacker was able to gather. So a lot of your open source information can be used for spear phishing because they're able to customize the attack for that individual, and they're really working on maybe 1 to 2 people within a company. So that can be a lot more targeted. These are the references that we use for today. Thank you so much for your time, and have a wonderful evening.